Today we're talking about the light RTM, and one of the things that we'd want to talk about is being able to have a gel-coated part on both sides is one thing. The second thing we're looking at something that in the industry where I'm at in my territory is a lot of marine. So they're looking for something that is repetitive to be able to do over and over and over again. So they're looking at their cost on the resin, they're looking at their cost on their glass, and what they know, a fixed cost that they have on every part is very repeatable.
Morning. Again, what we're looking at here is a standard A-side tool is basically like your open mold tool, only with a different flange configuration, and also being made out of a different product. I mean, with closed molding of any kind, you're insulating, especially with light RTM, you're creating a cavity, you're going to put your glass in, you put the B-side mold on top. Because this part takes like less than 2 minutes to inject, you're going to be looking for something that has a much faster cure, and so therefore you're going to create a lot more temperature, and so your HDT is going to be higher than it would be in open molding, certainly trapping it in there. With the A side, the B side, then again, you come up with, you've got your flange area. This is our wing seal, which keeps atmospheric pressure out. This is the clamping pressure, that is the closing pressure of the mold. And then we have another cavity, which is our cavity for the part itself. The silicone seal here, the mushroom seal, is the border between your vacuum seal, clamping seal, and your cavity part. We've got a resin runner that comes around to distribute the resin. You're going to see that when we inject it. And also we have, what's really important too, is these are what we call zero shutdowns. So this is an index point that's going to close the mold, and when the mold closes, it's going to hit these two hard stops, and that is the designated area that we know we can have the exact thickness that we want. We're not relying on the seals to create our cavity thickness. So
what Steve is holding up here is the part that is finished. In this particular case, we did apply the gel coat off-site. We're not allowed to spray any materials in the convention center here. So you'll see what the finish quality is on that material. We start off here is with the image gel coat material that we developed several years ago. In particular, it's called PCT 100, and the advantages is it basically was designed for deep, dark colors, particularly under waterline applications. So it's much improved on blush resistance, much improved on the wear resistance. I'll show you some data on that as well. And then also much improved for UV resistance. It also is MAC compliant for the marine industry as well. Very low porosity, and it's very easy to repair and patch if it gets damaged.
My name is Travis Irvin. I'm with Shomrot. Like Rick mentioned, the product we're using today is called Rovacor. Rovacor was originally developed specifically for closed mold processes. When closed molding was initially developed years ago, it became pretty much immediately obvious that traditional fabrics were not ideal for trying to sandwich between two hard tools. So what we developed is a combination of chopped glass fibers and a polypropylene core in the middle of it that's lightly stitched together. The polypropylene core serves a couple purposes. It allows the resin to flow evenly through the parts. It also, because it's both compressible and it has rebound, it makes up for some of the differences in the mold cavity. There may be areas that are a little tighter, areas that are a little looser. There's spring back in this, it'll open up so you make sure you have glass touching both surfaces. And like I said, it can also compress, so if there's areas where you've got layers that are overlapping, still allows resin to flow through there, so you have a good, strong part.
Well, today what we're using for this demo is our Patriot Pro Innovator. This is our most basic system for closed mold applications, that being light RTM, reusable bags, or even VIP process. We have a 7-to-1 Patriot pump on this system. We have our catalyst pump right here. What we like to do usually before we even get it, when we get into the shop in the mornings, we like to put this into recirculation. And when I put it into recirculation, you're actually going to see your catalyst pump pumping catalyst back into our catalyst jug, and then our resin pumping back into our resin bucket.
This is going to be our vacuum port for the cavity itself. They're mounted on two O-rings. And this is our catch pot. This is the waste we had for the last 3 parts that we made. And what you're going to see is that we put a cup in here so we don't have to clean this out every time. Makes it a lot easier and very inexpensive disposable. This vent here is comes into our waste area. And this is what we're going to waste. Now, in a real world, we wouldn't use a piece this long, but certainly all you need is this is all you're going to need to waste. So what we've done, we plug this in, and this hose goes in here. It's trimmed off exactly flat, so it doesn't leave a mark on the part from that. And also the fact that when we're finished, we're going to push the clip down. We'll be able to pull that hose out after it's cured, and it's ready to use again. Put a new hose in, and you're ready to go again. We're going to pull about 26 inches here on our peripheral vacuum, and we're going to come up to around 15 inches on our cavity itself. So we're going to be injecting at about 17 psi. You see we've collided here. You're starting to see that it's coming right here. As the resistance of the glass accelerates, you're going to see that slow down, and this is going to speed up. It's just very simple flow. So having the stroke counter, as Andrew said, we know exactly how much we're putting in every time. For company owners, for fit and finish in the future, you know, it's super important that every one of those parts are exactly the same thickness, going to be the same weight, so it's going to fit the same. You don't have to go back and back face it. Certainly you could gel coat both sides if that was what you needed, but oftentimes in the marine industry, if you gel coat the A side, pigment the resin the same color as what the gel coat is or close, the average person would not know the difference that it wasn't gel coated on both sides. You don't need the UV stability on the inside of a hatch, for instance. The valve's shut. You can see that physically because the pin's gone.
And you can see that Andrew just flushed out the product after it was done down in the bucket, got it shut off. You can see how much resin we wasted.